So next reaction we are going to discuss in detail about acyl-ion condensation process. This is the part of organic named reactions. The content taken from textbook of organic named reactions, which is written by Dr. Kavitha Kotthireddy Kota. The series of sessions whichever already completed based on organic named reactions available at the channel called World of Competitive Chemistry. Now we are going to discuss about acyl-ion condensation reaction. Acyloin condensation is a reductive coupling reaction of ester that produces alpha hydroxy ketones known as acyl ions, right? Valuable for carbon-carbon bond formation, especially alpha hydroxy ketones and cyclic compounds generated by this process. Two esters are taken and metallic sodium is treated with that one. There is a formation of uh, alpha hydroxy carbonyl compound is possible. This is said to be acyl ion. I am taking ester compound, sodium xylene taken as a solvent media, so that here is the formation of disodium salt. Disodium salt will be originated, and here is the treatment with hydrochloric acid and ketonization taking place. So ketonization taking place. In order to get this one, let me introduce this negative charge back polarizing, and this whenever this negative charge is back polarizing, this pi bond is moving toward this side, and that will be protonated as a acyl ion generation is possible, right? So here the reagent required is metallic sodium, and the solvent is a dry aprotic solvent like toluene or xylene, purely hydrocarbon, non-polar in nature. Tetrahydrofuran is also suitable solvent in order to blend all the reagent, all the reactants. That's the reason why dry aprotic solvent is suitable over here. Atmosphere, inert nitrogen or else argon can be taken. This is said to be noble gas environment. So here, whenever nitrogen or else argon that able to generate the inert atmosphere, so that atmospheric oxidation will be prevented. Temperature is mild heating is required, so that it is more important for the application perspective, right? How the mechanism taking place for the reaction? I'm taking ester, and here the reaction mechanism is taken in the form of electron free radicals only. Sodium free radical was taken. So added electron containing sodium free radical is the activated reagent, activated catalyst over there that able to bind up at the position number carbonylic carbon. Whenever here bonding takes place, only one electron, that's why half-headed arrow is indicated over there. That's the reason why here the pi bond cleaved in a homolytic fission, so that the electron will be joined over there, and there is a formation of negative charge. Electron, two electrons are moving there, so that here negative charge originated. Whenever sodium metal giving electron that is taken by the carbon get the negative charge. Anion radical originated counterbalanced by sodium positive metal ion, and this able to bind up with any other similar molecule whichever generated in the same manner. Being I'm taking 2 moles of ester, 2 moles of sodium radical is supposed to be treated at the carbonylic carbon atom, so that carbon radical generated are 2 moles which are taken in the individual molecule. So here is the carbon radical, here is the carbon radical. Both are susceptible to generate new carbon-carbon bond formation. Whenever new carbon-carbon bond formation taking place, methoxy located upon these two carbons, and here O minus Na both are present over there. When these compounds are participating in the bond localization in this manner, negative charge is back polarizing, methoxide is completely removed. Here you can experience the ketone. In the same manner, another negative charge is back polarized, and this methoxy removed diketone is the ultimate thing you can notice. This is a newly formed compound. This diketone again go for the reaction with sodium metal radical. So sodium metal radical is involving in the reaction with the carbon atom. So here bonded electrons are moving to oxygen atom. So that oxygen getting negative charge, the carbon experiencing odd electron from the sodium metal, that is carbon-carbon radical. So here carbon-carbon radical and the adjacent carbon atoms are highly unfavorable because of repulsions. And here is the oxide counterbalanced by 2 sodium metal ions. Simultaneously, two carbon radicals are able to form a new pi bond in between, and here you can notice still there are the O minus charges and the carbon atoms. The O minus charges are supposed to be protonated under water condition, aquated condition, so that here you can gain OH, here also OH will be generated. That is vicinal dihydroxy olefin formation. If it is tautomerized, so that enolic form turned into a ketonic one, and another carbon is experiencing hydroxyl. So here, in this manner, alpha hydroxy ketone is the ultimate product in this reaction, which is said to be acyloin. Acyloin is meant for hydroxy ketone. This is the way hydroxy ketone is generated if we are starting with 2 moles of ester compound in the presence of sodium metal. Examples with respect to this Acyloin reaction will be 2 moles of ethyl acetate is supposed to be treated with sodium metal. There is a formation of CH3CO, CHOH, CH3. CH3CO, CHOH, CH3 is the product, that is alpha hydroxy ketone. And the same reaction is given in the schematic form where I am taking C2H5, CH3, C double bond O, C2H5, this is ethyl acetate, and that to be treated with another molecule of ethyl acetate. Molten sodium metal to be taken. Tetramethylsilyl chloride is a kind of reagent added over the xylene reflux conditions are required, so that here one of the oxygen whichever present protected with the TMS, another oxygen also with TMS. Here is the double bond originated. Protonation followed by aqueous conditions if applied, you can notice alpha hydroxy ketone, which is said to be a kind of Acyloin. In order to get the entire mechanism in the clear manner, initially ester taken, electron accompanied by a sodium metal is added over this carbonylic carbon, and pi bonded electrons totally shifted toward the oxygen, so that radical anion is originated. That to be dimerized, 2 moles of the same radical anion is combined with a new carbon-carbon linkage, so the terminal oxides are originated. They are supposed to go for the back polarization of the bonds, and you can achieve the diketone. Diketone is reacting with 2 moles of sodium metal once again, so the 2 radical anions are originated. Further protonation giving rise to here O minus turned into OH, and here also protonation taking place. So whenever the dihydroxy compound generated ketonized, tautomerized, so that we can achieve double bond OH, which is called acyloin. In the simple manner, the entire mechanism is given. So this is the representation of acyloin condensation mechanism. I'm taking 2 moles of lengthy chain, that is ethyl butanoate, 2 moles conditions were taken, sodium metal was taken. So here both are supposed to go for the chain elongation reaction, being it is simply dimerization. One of the ester carbon is converted into ketone, another ester carbon is converted into hydroxyl. Here C3H5, here C3H5. So the chain elongation you can notice. This is the way acyloin is originated. And here I am taking that same compound is having one terminal ester, another terminal is also ester. Internal acyloin condensation taking place within. Sodium metal is operated. One of the terminal carbon turned into ketonic one, another terminal carbon converted into hydroxyl one. This is the way a kind of ring system is generated. I'm taking benzaldehyde and treated with pyruvic acid. Pyruvic acid and benzaldehyde. PDC is the mild oxidizing agent, so that here the formation of here the carbon converted into hydroxyl. Here the whichever ketone is there, that ketone remains, and carboxylic acid mildly replaced. And here the compound generated is called beta hydroxy ketone, called acyloin. This is phenyl acyl carbinol formation is possible. This is the phenyl fragment, this is the acetyl fragment, this is carbinol in between. So S-phenyl acetyl carbinol is the expected product. I'm taking COOMe at the terminal carbon atom sodium in the presence of xylene is able to react to give the keto hydroxy compound called acyloin. So this is internal acyloin reaction again. Once again, I'm taking a kind of beta keto ester. Upon the oxidation, the ester whichever present is accompanied by the hydroxyl in between. Alpha position hydroxyl will be generated later on. Same product is expected by condensing this ketone with the ketoester compound. So again, here the formation of hydroxy ketone is possible. Hydroxy ketone simply said to be what? That is acyl ion only. This is the way multiple examples noticed pertaining to acyl ion formation. Advantages and most important features pertaining with this kind of acyl ion formation will be carbon-carbon new bond formation is taking place at the alpha position. Alpha hydroxy ketones will be originated very important intermediates in the synthetic organic chemistry. Cyclic acyl ion condensation is possible when where macrocyclic Lorentz systems were taken. Alternative to aldol condensation, it resembles like aldol condensation, so that you can take this reaction as alternative for the aldol condensation. Alpha hydroxy ketones are needed, so this acyl ion formation reaction is more suitable to perform. Applications of acyl ion reaction. Synthesis of natural products are possible. Acyl ion natural products are former family of bioactive compounds, and myxobacteria fungi can be isolated from these acyl ions. The total synthesis of 7 members of acyl ion family was achieved via HW reaction, acyl ion reaction by Isayama hydration. Let me repeat. Isayama hydration process is accomplished in the presence of cobalt-2 and cobalt-3 catalyst. If base is applied, salpin complex is also taken as a catalyst over there, so that enone hydration will be generated. This is the way the important natural products will be generated by this acyl ion reaction. Macrolides. Macrolide synthesis, crucial aspect of organic synthesis, involves the construction of macrolides, a class of compound characterized by large ring lactone structure. This compound significant in pharmaceuticals and natural products due to their biological activities and potential therapeutic applications. Macrolides will be there. Macrolides synthesis also taken by this acyl ion reaction, right? Fragrance. Volatile acyl ions are being hydroxy ketones are said to be a kind of fragrant agent, so that they are volatile in nature. They diffuse very easily, and some pleasant smell is also indicated, so that order quantities and threshold values of 34 acyl ions were evaluated. 23 of them are distinct flavoring agents. So that they works like a flavor in the food industry. Intermediate for amino acid synthesis, polyketides as well. So these kind of compounds generated starting with the acyl ions, antimicrobial. So they are having the inhibitory activity towards the microorganisms which are inducing various diseases like bacteria, virus, algae, fungi, protozoan, etc. Indole containing acyl ions are either key intermediates of many antimicrobials, antiviral natural products, building blocks for synthesis of biologically active molecules. As such, access to structurally indole containing acyl ions are attracted considerable attention. This is the way acyl ions plays a vital role in the field of synthetic organic chemistry. Multiple applications are provided, and multiple synthetic routes also explored by means of the research. Later on, we will fetch into this alphabetical order named reactions we are discussing about. Next, B related named reactions are going to be discussed in the next session. Bayer-Drewes and indigo synthesis is content for the next session. Hopefully, the session is very informative, and acyl ion synthesis and its related applications, everything in detailed manner manifested over there. So subscribe the channel and watch the content continuously, so that you will get the sound knowledge in chemistry. Thank you one and all for your patience.